Consider f of x, find the value of k if x plus 2 is a factor of k. So when we substitute in -2, we should get out 0. So we're going to have 0, -8, that's 4, times -2 is -8, plus 10, plus k, so -16, -6, positive 6 should be k. When the function is divided by x plus 1, the remainder is -20, find the value of a. So when we substitute in -1, we should get -20. Minus a plus 6. Okay, so that's going to be positive 6, -11, -22, and minus a plus 6, so -5, -27, -21, plus 21, so positive 1 should be -a, so a should be -1. When that's divided by that, the remainder is 8, so we have 8 equals positive 1 to the 4th plus a plus 3, so that's 4, a should be 4. The polynomial is divisible by x minus 2 and has a remainder. Okay, so we're going to have simultaneous equations. So we're going to have 0 when we substitute in 2, cubed is 8, 2 squared is 4, 2, okay, so 2 plus 4a plus b is the first one, and then we'll have 6 when we substitute in -1, so that's going to be -1 plus a plus 3 plus b, so 2, and when we subtract 2, 4. Okay, so I'm going to write this as -2 is 4a plus b. So when we subtract these two, we're going to have -2 minus 4 is -6, 4a minus a is 3, and b minus b is the whole point to get rid of that. So a is -2, and we'll substitute that in here. So 4 equals -2 plus b, so b is 6. Factorize completely p at x and state its roots. So that means that, and I'm just going to do synthetic division because we've got a linear factor. So 1, a is -2, and -3, and then b is 6. So I'm just putting the coefficients of that. So we bring down the first one and then multiply 2 times 1, which is 2, and then add. And then 2 times 0, which is 0, and then add. And then 2 times -3, which is -6, and then add. So that means that we'll have x cubed plus minus 2x squared minus 3x plus 6 is equal to x minus 2. And then remember, if this is x cubed here, when we divide it, we're going down. So this is x squared, x and the constant. Okay, so we're going to have x squared minus 3. And its roots are 2 from this one, the first one, and then plus or minus, square root 3 from the next one. Alright, so we've got -1 equals when we substitute in -1. So that's going to be -a plus b cubed. And a remainder of 27 when we have 2a plus b cubed. Okay, so We can take the cubed root, so that's negative 1 equals negative a plus b, and the cubed root of 27. So now we can subtract these two to eliminate the b. So we're going to have negative 4, negative 3a. So a is 4/3. And then if we put that into either, I'm going to put it into this one. So we have negative 1 equals negative 4/3 a. Not a. A is negative 4/3 plus b. So when we add 4/3 to the other side, we're going to have 1/3. Okay, so the polynomial leaves the same remainder, we'll call it k, when we divide by 2 and negative 1. So when we substitute in 2, it's 8 plus 12 plus 2x plus b, so 20. This is supposed to be an a. And for the next one, when we substitute in negative 1, that's negative 1 plus 3 minus a plus b. So this one is going to be 2 minus a plus b. Okay, so if we subtract these two, that's 0. It's 18. That's 3a, and that's eliminated. So this should be a is negative 6. So the possible values of b. So when we substitute that in, so we're going to have k is 20 minus 12 plus b, and k from this one is 8 plus b. And same for this one. So if we were to solve both these for b, we get b equals k minus 8. It looks like b can be anything, because k is just some remainder. So k can be anything, and b is also anything. Okay, so these are factors from the value of p and q. So if we substitute in 2, we get 0. So 8 plus 4p plus 2q plus 4. So negative 12. And if we divide by 2, and then if we substitute in negative 2, we get 0. And minus 2q plus 4. So negative 4, positive 4. And divide by 2. So here we can subtract these again, these two. So negative 6 minus 2 is negative 8. The p's eliminate, and that's going to be 2q. So q is negative 4. I'm going to put it into this one. So negative 6 equals 2p minus 4. So plus 4, negative 2. So p is negative 1. All right, this one divisible by 1 and negative 3. So substituting in 1 for x, a plus b is 2, and then negative 3. That's going to be negative 27, negative 54, plus 9a, plus 12, plus b. All right, so that's going to be negative 42, positive 42 is 9a plus b. So if we subtract negative 40 equals negative 8a, so a is 5 and b is negative 3. So if we're factorizing this, we're going to have p at x equals 2x cubed plus 5x squared minus 4x minus 3. And if we divide that, so let's do long division this time. So this goes in 2x squared times, so that's 2x cubed minus 2x squared, and then subtract. So that's going to be 7x squared, then bring down, and then that's going to be 7x. So then that's 7x squared minus 7x. And then that's going to be positive 3x minus 3, and then plus 3x minus 3. So at this point, we have 2x cubed plus 5x squared minus 4x minus 3 equals x minus 1 times 2x squared plus 7x plus 3. Now I will do synthetic division with the 2, the 7, and the 3. Bring it down, negative 6, add negative 3. So then we've got x minus 1, x minus 3, actually plus 3. And then last, this was x squared, so this is x in the constant. Okay. The polynomial is a factor of that. Calculate the value of the constant a. So let's long divide. 1 a minus 4, 3, I'm mixing things, sorry, and then 3 minus 4a, x plus 3. Okay, so this goes in x times. We're going to have x cubed minus 4x squared plus 3x. So now, I think this is one way you can do it. I don't know, this is going to get messy. The other way we could do is factor it, but we'll deal with that in a second. So this is a minus 4 plus 4. So this is just ax squared. And then that's 3 minus 4a minus 3. So this is just negative 4a x, and then bring down the 3. All right, so this has to go in a times. So that's ax squared minus 4ax plus 3a. Subtracting, the first two go away, and then 3 minus 3a is the remainder. So we know that this has to be 0 because it says it's a factor, so that means a is 1. Like I said, the other way we could do it is just factor that x squared minus 4x plus 3, which is x minus 3x minus 1. And then we could substitute, so we're going to have 3 in there, 27 plus a minus 4, 9 plus 3 minus 4a, 3 plus 3, which simplify, and this will equal 0, plus 9a minus 36 plus 9 minus 12a plus 3. So we've got 39 minus 36 is 3, minus 3a is 0. Okay, And if you substitute in 1, you get the same. Okay, so either way, a is 1. Okay, so that means that we have x cubed minus 3x squared when we put in 1 minus x plus 3 is going to equal to x minus 3, x minus 1, x plus 1 because of this guy. Okay? And find the remainder when the cubic is divided by, so we just need to substitute in 2. So I have 2 cubed, I'm doing it in here, or we can do it in here. So if we substitute in 2, we're going to have negative 1, 1, 3, so negative 3 should be the remainder. All right, consider the cubic. Find a and b in each of the following cases. All right, so a, it's divisible by 1 and leaves a remainder of 6. So we have 0 equals a plus b plus 3 plus 4. So negative 7 is a plus b. And 6 equals negative a plus b minus 3 plus 4. So 1, 5 equals negative a plus b. So we subtract. So negative 12 equals 2a. So a is negative 6 rather, which means b is negative 1 when we substitute it into either one of those. So that's a. B, it's divisible by that. So we have, this is equal to x plus 1, x minus 1. So we need to substitute those in. So we're going to have the same case when we substitute in 1 from above, so a plus b plus 3 plus 4. And then this one is going to be equal to 0 when we substitute in negative 1. So that's 1, negative 1. So subtract negative 6 here, 2a, and the b's go. So a is negative 3, so b is negative 4. And c, f at x leaves a remainder of that when we substitute in, okay, so this is going to be a plus b plus 3 plus 4, so 7 minus 7 and I suppose we're also substituting in 1 for that, so that's going to be negative 7 as well. Okay, and the other side, so when we substitute in negative 1, so this is actually going to be positive 3, 6, and minus 1, 5. Okay, so we should get a is negative 6 here and b is negative 1, just like the first one. Okay, when we substitute in 1, we get negative 2. And when we substitute in 2x minus 1, so 1/2, we get 13 over 4. So 1/2 cubed is 1/8. 1/2 squared is 1/4. And then 1/2 cube. And then 1. And we'll simplify this down. So that's 1 over 2. 1 over 4. 1 over 2. And if we multiply through by 4, we get rid of the denominator. So 13, 2p, 2q, 4. So 6, 13 minus 6 is 7. On this over here, this is 5, negative 7. So 7, subtract. So negative 14 eliminates q minus 2q is negative q. So q's 14, which means 14, negative 21 is q, p. So when we substitute in 1, the remainder is 17 minus 21 over 2. Okay, so then that is negative 2 on the right, and p plus q, and then 5 and minus 5, so this is negative 7 here. Okay, so then this one, when we substitute in 1/2, we're going to have 4 1/8 plus 1/4 p plus 1/2 q plus 1 equals 17 minus 21 over 2, because it's 1/2 over 2. Okay, so this is 1/2. If I multiply through by 2, I get 1 plus 1/2 p plus q plus 2. Okay, so then 3 minus 3, so that's 14. P plus q, 1/2 p. And then multiplying through by 2, we're going to have p plus 2q equals 28 minus 21, 7. Subtract. So this is negative q equals negative 14. And then back in here, so p is negative 21.